this is Patrick at 1CNC West, and what we're going to do in this training video is continue to apply toolpath to our part geometry. Now remember, we're applying toolpath for the subspindle toolpath group. In fact, in the last video, we performed a lathe finish profile operation, which you can see right here. And before that, we had performed a roughing operation, which you can see. Now in this video, what I'd like to do is demonstrate how we can perform a machining operation that will remove material from the very face of the part. Before we do that, we don't need the solid model, so I'm going to hit the letter S on the keyboard to go into select mode, and then I can left click that solid model. And now I can temporarily hide the solid model by using the blank command. Now a shortcut for the blank command is simply hitting the letter B on the keyboard, just like that. It should also be noted that you can access the blank command up here on this top toolbar. Now in previous videos, when we performed a facing operation, we had used a command called face. This machining operation is 100% dedicated to performing facing operations only. All right, very versatile. It's a great command. But what I'd like to show you is that if you'd like, you can actually use the turn face finish machining operation to remove material from the face of the part. Now before we do that, I do need to measure the distance from the very top of this chamfer to the very bottom. Now the reason for that is we're going to be selecting just this vertical line for our facing operation. So I need to know how much I need to extend the toolpath so I can go past center line. Now to measure that distance is very easy, and 1CNC supplies a couple of different ways to do that. We're going to head down to the lower right hand corner, select our verify tools, and we're going to use this option, which is fourth from the left, called retrieve a distance between two pick positions. This is like a measuring tape, and all you need to do is take your cursor and left click, and then we're going to come down here and left click as well. Now if we look within the results in the lower right hand corner, you can see that the Y distance is 425 thousandths. Now there's something else I want to point out. Notice how these values are in X, Y, and Z. And that's because by default for CAD only, 1CNC uses the mil coordinate system for CAD, and that's what you're seeing in the lower left hand corner. For manufacturing, for the CAM side of things, 1CNC is of course going to output X and Z, and that's what you're seeing right here. So CAD, X and Y like milling, for CAM, X and Z for your turning toolpath. Now if you'd like, you can set up 1CNC so that it also uses X and Z for the CAD side of things. Let me demonstrate how to do that. Take your cursor, head up to the upper left hand corner, select File, 1CNC Properties, and within this first dialog box, just click this option under Coordinate Format that says Z, X, and Y, and then click OK. Now watch what happens. I'm going to use the exact same verify command. I'm going to left click the top of the chamfer, left click down here with just like that, and notice now that the distance is represented in X. So within 1CNC, you have the flexibility to output these values in Z and X or X and Y, whatever coordinate system is most comfortable for you. All right, so we want to remember this 425 thousandths. If you'd like, you can highlight that, right-hand mouse click, and select copy, and 1CNC will put that value within the clipboard. I'm going to hit escape, going to zoom out just a little bit, and let's head over to the command manager. And what we're going to do is select our turn face finishing operation. I'm going to take my cursor and left click just that vertical line, and now we're presented with the four arrows. I want to machine on the outside. I want to machine from the top to the bottom, so I'm going to left click that arrow. Now because that's the only piece of geometry that I'd like to apply toolpath to, I can simply right-hand mouse click, and then 1CNC will bring up our very first dialog box. Just like with these previous machining operations, when defining a tool, we need to select a tool from the tool library. Now you can access the tool library by clicking on the tool changer button or just left clicking on the tool graphic. I'm not going to do any of that because I want to use the exact same tool that I had used before. I'm going to leave the turret position alone, even though I may come back and edit that a little bit later on Don't need to worry about the tool offset. We're going to have that set to 1 as well. Coolant and work offset, we're just going to be using the defaults that the OneCNC post processor is going to output. For this, I'm using inches per rev at 5 thousandths. My RPM is set at 550. And of course, you can use constant surface footage. If you'd like, you can also set up a max spindle if you want. You can also overwrite the spindle direction by just activating this option and clicking whatever direction you'd like. I'm going to uncheck that and use the default. And as discussed in our previous video, you can also output notes if you want to. I'm going to leave notes alone. Notes is the ability to type in whatever you'd like, and those notes will appear within the CNC code. I'm going to leave that alone for this example, and let's click Next. Now here we're presented with the clearance style. This is how the tool is going to move away from the part geometry after the tool path. Typically, 95% of the time, you'll never have to change this. The only time you'd want to modify how the tool exits the machining operation would be if you're performing more complicated toolpath. But typically, you can leave this set to just no move. I think that looks good, so let's click Next on that. All right, we have two options here. We have Select Boundary or Select Contour. We're going to be using Select Contour because we want to apply toolpath to the geometry we had selected earlier. Also previously noted in our last video, if you have a rectangle created, you can also restrict the toolpath to a rectangle by using this option called Select Boundary. But we're just going to leave it set to Select Contour just to keep things nice and simple. Now, Z clearance and X clearance, this is where OneCNC is going to move the tool at the very beginning of the toolpath and where OneCNC is going to move the tool at the very end of the toolpath. And let me explain how this works. The Z clearance and X clearance in this example are measured from the very beginning of the geometry that we selected here. Z clearance of 200 thousandths simply means that the tool is going to start 200 thousandths in front of the part. And then the X clearance of 200 thousandths means the toolpath is going to start up here at 200 thousandths away. And so the actual start position will be X 200 thousandths, Z 200 thousandths, right about there. All right, so what is the minor X clearance? This gets used for when you're performing a facing operation. Remember that 425 thousandths? That's the distance from here to here. So if we wanted to, we could come over here, right-hand mouse click, and select Paste, and OneCNC would paste in that value. That's going to tell the toolpath to go an additional 425 thousandths all the way to centerline. Now in actuality, you'd probably want to go a little bit farther than that, so why don't we change that 425 thousandths to 450 thousandths. When you're using the profile operation for facing, the approach distance is the distance the tool is going to approach along the Z-axis. And here we have it set to 100 thousandths. Let's click Next on that. All right, so here are the main parameters for our facing operation. We have longitudinal or facing. We definitely want it set to facing. Auto simply means that we're going to cut in the direction that we selected the geometry. That's from top to bottom. That's absolutely what we want, so we don't need to change that. We're not going to take a look at Smart Finish in this video, but we will take a look at that in future videos, so we're going to leave that alone. For cutter compensation, you have automatic default, and what this does is this tells OneCNC to account for the tool nose radius. If you don't check that, if you click this set to none, then OneCNC will not look at the tool nose radius and it will just guide the tool by the theoretical control point. Typically, you want it set to automatic default, so OneCNC does indeed recognize the tool nose radius. In addition to this, you can output cutter comp by using any of these three options right here. All right, we're going to leave that set to automatic. For cut control, you can take several passes, but let's just leave it set to 1 for that. And for finish allowances, we're going to leave this set to X0, Z0 because this is going to be a finish pass. We don't need to worry about groove control because we have no grooves, but you can see that with cut groove set to off, the toolpath will ignore grooves. If you have it set to on, OneCNC will take the tool and cut inside the groove as far as it can without violating any of the geometry. So it really doesn't matter what we have this set for in this example. We'll click next on that. All right, so now we have our cut from start and cut from end. We talked about this in great detail in our last video, but let me just quickly set this back to the defaults just to give you a quick overview of this. Cut from start is how the toolpath begins. If you leave this unchecked, you're going to notice that OneCNC takes the theoretical control point of the insert and puts it at the very beginning of the geometry. If you activate this by clicking, notice now that the toolpath is going to take the tangency of the insert to begin the toolpath. And of course, if you click entry amount, you could type in a value, and it's going to tell OneCNC to start a little bit before. In this example, 50 thousandths. That means the toolpath is going to start 50 thousandths before the beginning of the geometry. Cut to end works exactly the same way. If it's unchecked, OneCNC will take the theoretical control point and take it to the very end of the geometry, plus whatever other amount we'd added on there earlier. Remember, we added 450 thousandths. But if you click cut to end, OneCNC will take the tangency of the insert to that location. And of course, you can also add an additional amount if you want to. Okay, I think all that looks good. Let's click finished and let OneCNC generate the toolpath. You can see the toolpath has started 200 thousandths away in X, 200 thousandths away from Z. It's rapided till it came to 100 thousandths before it's performed that approach value or that approach move of 100 thousandths. And then we fed, and then we've gone past the very end of the geometry, an extra 450 thousandths. We've moved away from the part, and we have returned back to X of 200 thousandths and Z of 200 thousandths. All right, that's it for this video. Thank you so much for watching, and I look forward to seeing you in the next video.